Hey everyone, we're going to kind of keep on going here with the idea of logarithms and exponents. And I know we didn't really spend any time reviewing your logs from Math 30, but we are going to kind of spend some time reviewing logs from Math 30, but we're going to reference everything in terms of base e. So again, e is that awesome number when you graph y equals e to the x. The slope anywhere in y equals e to the x is always e to the x. So that's kind of cool. Now, what we learned back in Math 30 is that you can graph logarithms because they are just basically an inverse function where you switch the x and y's around and you kind of go from there. So when you graph y equals e to the x, it's an exponential growth. When you graph y equals the natural log of x, and natural log of x just means log of x to the base e, but this is kind of cumbersome, so we just call it natural log. So the same way that e kind of has its own special designation, natural log ln has its own designation as well. And you can actually find that button on your calculator. Who knew some of these things existed, 2 months ago? Anyways, the way you graph natural logs, of course, you just switch your x and y's around. And one of the things that we always look at is the point that was 0 and 1 becomes 1 and 0. As the range here is always larger than 0, so when you do the x and y switching around, now your domain is always larger than 0. So your function is continually increasing on an exponential growth, and that means that your function will be continually increasing on a log growth function as well. So then if you understand again the idea that exponential functions and log functions are simply just switching your x and y's around, we can kind of go forward and just look at some of the similar skills between base e and base 10 or base e, base 2, base 3, whatever base you have. So when you see natural log of e, just remember that means log of e to the base e. And what you learned back in Math 30 is if your bases are the same, the answer is the exponent. So here your bases are the same, so the answer is just x. Here, mathematically, when you have base e and the exponent is log x to the base e, sometimes we just like to kind of change this so it equals something. So it equals y, and now we just want to solve for x. So how do you solve for x? Well, again, your base is e. So this e is this base e, and this natural log of x is the exponent. So the exponent is the answer. So log of y to the base e equals natural log of x. So now what you actually have happening here is that this log base e is the exact same thing as natural log, which means y equals x. So if you have this expression, e equals the natural log of x, then the answer is just going to be the x. So if this was e to the natural log of x squared, your answer would be x squared. If this was e to the natural log of x cubed, it would be x cubed. For c here then, natural log of e. So again, natural log means log base e. If your bases match, the answer is the exponent, so the answer is 1. And again, for this is, how do you get an answer of 0? That means your exponent was 0. So e to the 0, right, is your answer. Sorry, e to the 0 is 1. So 0 is your exponent, 0 is your answer. And then how do you solve equations? Again, a lot of us, as we're kind of learning, even back in trig, we did a lot of work with radians, but a lot of you default back to degrees because it's more comfortable. So when you see natural log of x, you might just default to log x to the base e for a while until you get comfortable, understand that your base is e. So e is the base, 5 is the exponent. Solve for x. How do you get rid of a base? You take the logarithm to kind of match that out. So if you take the natural log of e, the bases are the same, the answer is the exponent, and then the natural log of this number is 3. And that's one of the ones that we used in our graph a couple of days ago. Similarly here, base e, so take the natural log, so the answer is the exponent. Natural log of 4 is just a constant number. It's an irrational number, so we don't simplify it. Do some algebra, fewest negatives possible, add 2x, subtract natural log of 4, and then divide by 2. So just kind of solving a two-step equation there. Sketching, looking at reflections. What happens when you have a negative natural log, right? That's just a reflection in your x-axis. a positive y value becomes a negative y value, and negative y value becomes a positive y value. So you've got that reflection. And here you've got a reflection in the y-axis. What was on the right side goes to the left side. So reflections still work just like you did in Math 30. Expressing as single logarithms, this is something you worked on a lot in Math 30. When you have a minus sign, it means you're dividing with your like bases, and when you have an adding sign, it means you're multiplying with like bases. Those are rules of exponents, right? You multiply, you add exponents. When you divide, you subtract exponents. And when you have the power rule, so the 2/3 natural log of x, this 2/3 is the exponent for the x. The 4 is the exponent for the y. All right, so that's kind of what we did here. X to the 2/3 divided by y to the 4th multiplied by x plus 1. And then domain and range, that kind of idea. We know that natural logarithms, and there's a graph here, this little blue guy, we know the domain is larger than 0. So 16 minus x squared has to be larger than 0. 16 minus x squared has to be positive. The only way for that to be possible is for the x's to be between the 4's. Right? Once you put 4 in here and negative 4 in here, you get 0. So you can't even include the 4's, so it's negative 4 to 4. And then what happens is as you approach 4 from the left side, as you would approach 4 from the left side. So again, if you're kind of approaching 4 from the left side, what happens? You get closer and closer to a small positive number. In this case, you get closer and closer to negative infinity. So again, when I say getting closer and closer to a small positive number, it's 16 minus 4 squared, or 16 minus almost 4 squared is a really small positive number. And when you get a really small positive number, you're approaching negative infinity. All right, so that's kind of a quick review then for properties of logarithms, and in particular properties of logarithms that have base e. So again, whenever you see natural log of x, it means log of x to the base e.